Hello everyone, welcome to online classes. Today in this video we will discuss chapter 3 Understanding Quadrilaterals. Now before moving forward we will discuss some basic concepts. First one, curve. Any line can be a curve. It can be straight or bent. In daily life, straight line is not a curve, but in mathematics, straight line also considered as curve. Now, how to draw a curve? That is, we can draw a curve without lifting the pencil from the paper. We can draw a curve like this without lifting the pencil from the paper, or we can draw the curve like this without lifting the pencil from the paper. So here I have drawn some curve at the top. These are some examples of curves. Now simple curve. Simple curve means a curve which does not cross itself. Simple curve. If it is crossing like this, it is not a simple curve. Or if it is crossing like this, it is not a simple curve. Therefore, simple curve means the curve which does not cross itself. This is also a curve, but it is a simple curve. It does not cross itself. Now, simple closed curve. Here you can see, if you are starting, when you draw a rectangle, you can start from the point. If you are starting from a point, we can come back to the same point. So, if the starting and end points are same, that type of curves are called closed curve. Therefore, here it is an example for simple closed curve. This is simple because simple curve. Therefore, because it is not closed itself, at the same time it is closed also. Therefore, these three are the examples, some examples for simple closed curve. In all the three cases, it is an example for simple curve because it does not close itself. At the same time, it is closed also. That means starting and end points are same in all the three cases. That is, if we are starting from a point, we can come back to the same point. Therefore, it is a closed curve. Now, polygon. Polygon means that is a simple closed curve made up of line segments only. That is, all the sides are made of line segments. Here, if you are taking an example, when you draw the circle, it is simple closed curve, but it is not made up of line segments. So, this is not a polygon, but here it is a simple curve because it does not cross, it is closed also. Starting point and end points are same, but at the same time, all the sides are made up of line segments. Therefore, it is called a polygon. That is, polygon is a simple closed curve made up of line segments only. Now, diagonals. Diagonals means in a polygon, the line joining non-consecutive vertices. Here, when we draw a rectangle or any polygon, different types of polygons are there. That is, this is called triangle. The name of this polygon is triangle, and four-sided polygon, that is quadrilateral, five-sided polygon, pentagon, six-sided polygon, hexagon, seven-sided heptagon. Like that, different names are for different types of polygon. That is according to the number of sides. Now, here now we are discussing diagonals. So here I have drawn one rectangle rectangle ABCD, and here the vertices. Vertices means corner points. That is, A is the first vertex. Vertices is the plural of vertex. So A is the first vertex, then B, C, D. These are the 4 points, corner points, and these are called the vertices. And diagonals we can draw by connecting two non-consecutive vertices. Here if you are considering A, when you consider A, if you consider A, B and D are consecutive vertices. Consecutive vertices means just near to it. That is, after A, the next vertex is D. From this side if you are taking, after A, D is the next vertex. Diagonal is you are drawing two non-consecutives. Here B and D are consecutive vertices. So the remaining vertex is C. So we can draw the diagonal up to here. Diagonal we can draw from A to C. From A to C we can draw the diagonal. That is, diagonal we can draw by connecting two non-consecutive vertices. Here one from A I can draw only one diagonal. Now from B. From B, if you are considering B, A and C are consecutive vertices. That is just near. When you consider B, A is the next vertex on this side, and on this side C is the nearby vertex. So A and C we cannot draw the diagonal. We can draw the diagonal from B to D. So this is the next diagonal. So in this rectangle we can draw two diagonals. Now next point we are discussing is concave polygon. Or first we will discuss convex polygon. That is convex polygon. Convex polygon. That is, when we draw the diagonals of a polygon, if all the diagonals are coming inside the polygon. When you draw the polygon, if all the diagonals are coming inside the polygon, then it is called a convex polygon. For example, when you draw the diagonals, here this diagonal is coming inside, not going outside the figure. So this is a convex polygon. Now the next one. In this figure also, when you are drawing diagonals, all the diagonals will come inside. If you are in a pentagon, hexagon, all these type of polygons, when you draw the diagonals, it will be inside the figure. These type of polygons are called convex polygon. And one more thing is concave polygon. Next one is concave polygon. Concave polygon. Here concave polygon. Here you can give the name A, B, C, D, E. A, B, C, D, E. Here when you draw the diagonal, from B when you draw the diagonal, it will come outside the figure. Actually the figure is A, B, C, D, E. And when you draw the diagonal, this diagonal is coming outside the figure. therefore it is a concave polygon. If any one of the diagonal, at least one diagonal is coming outside the figure, then it is called a concave polygon. These are the some basic concepts we are discussing here. Now we will discuss the next point, regular polygon. That is, if in a polygon all the sides and angles are equal, it is called a regular polygon. All sides and all angles are equal in a regular polygon. Here I have drawn the three-sided polygon, that is triangle. Here all the three sides are equal. A, that is sides AB, BC and CA are equal, and angle A equal to angle B equal to angle C. Therefore, we can say this is a regular polygon. Regular polygon means all sides and all angles are equal. Now, we will discuss first exercise, that is exercise 3.1. Here I have drawn some figures and the question is classify each of them on the basis of the following. In that first we have to check whether the given figure is a simple curve. First we have to check whether the given figure is a simple curve. Simple curve we can draw without lifting the pencil from the paper. Without lifting the pencil from the paper, we can draw. So it is a simple curve. Curve. It is a curve, and also it does not cross itself. If it is crossing like this, it is not simple. Or if it is crossing like this, it is not simple. But here it is not crossing. Also, we can draw that figure without lifting the pencil from the paper. That is, when you start, only at the end you have to take the pencil or pen from the paper. So it is a simple curve. Now check whether it is therefore for A is satisfied. Condition A is satisfied here. Now simple closed curve. Here it is a closed one. That is starting and the end points are same. So B is also satisfied for the first figure. Now polygon. Polygon means simple closed curve made of line segments only. Simple closed curve made of line segments only. Here this simple closed curve is made up of line segment only. Therefore, the third condition, that is a polygon. So that is also satisfied. Now next one is convex polygon. Here you can see when you draw the diagram, one diagram will come outside, because you can see these are these vertex and these vertex are non-consecutive, and by connecting non-consecutive vertices we can do the diagram. Consecutive means when you take this point, this is the next vertex and this is the next vertex. This here you cannot draw the diagonal, but diagonal you can draw by taking two non-consecutive vertices. So these two are non-consecutive vertices, so you can draw the diagonal, but that diagonal is coming outside the figure, therefore it is not a convex polygon, it is a concave polygon. Therefore this D is not satisfied for this, E is satisfied. It is a concave polygon because one of the diagonal is coming outside the figure. So answer is A, B, C, E. That is A is satisfied, B is satisfied, C also satisfied, and E also satisfied. That is, without lifting the pencil, we can complete the figure. Also, it is not crossing itself. Therefore, it is a simple curve. So, first condition is satisfied. Now, simple closed curve. Closed means starting and end points are same. You can draw like this. That is, starting and end points are same. So, it is simple closed curve. Now, polygon. Polygon means made up of line segments. Simple closed curve made of line segments. Therefore, it is a polygon. Therefore, A, B, C is satisfied. Now, convex polygon. Here, when you draw the diagonal, it will come inside only, inside the figure only. So, it is a convex polygon. So, condition D also satisfied. Now, obviously, concave. It is not a concave polygon because it is a convex polygon. Now, comes to the third figure. Here you can see it is a simple curve because we can start from here and without lifting the pencil, we can come back to the starting point. Therefore, it is a curve. And it is simple also, it does not cross itself. Now, so first one, simple curve, that is satisfied, and simple closed curve, it is closed, that is starting point and end points are same. So, it is simple closed curve. It is a simple closed curve, but you can see all the sides are not made of line segments. Here this is not a line segment. So, it is not a polygon. Then if it is not a polygon, these two are not applicable. Okay, convex and concave is not applicable since it is not a polygon. Therefore, A and B are satisfied for the third figure. So, by like this you can check the remaining figures also. Now we will discuss number of diagonals in a polygon. That is, without drawing the diagonal, we can count. That is, if the polygon number of sides, if you know, we can find out how many diagonals we can draw using this equation. That is, n into n minus 3 divided by 2, where n is the number of sides of a polygon. Suppose a polygon with 3 sides. If the number of sides n equal to 3, and you know 3-sided polygon is triangle. And now you can find out how many diagrams you can draw in a triangle. That is, you can substitute the value. That is, here equation is n into n minus 3 divided by 2. And here number of sides is 3. Therefore, this becomes 3 into 3 minus 3 divided by 2. That is 3 into 0. 3 by 2 into 0, that is equal to 0. That is, for a triangle, we cannot draw any diagram. Now we can take n equal to 4. That is, for a quadrilateral. 4-sided polygon is quadrilateral. Therefore, instead of n, we can give the value 4 because it is a 4-sided polygon. Now we are going to find how many diagonals we can draw for this polygon. That is, we can use the equation. This we have to by that n into n minus 3 divided by 2. So, put n equal to 4. This becomes 4 into 4 minus 3 divided by 2. That is equal to 4 into 1 divided by 2. Now 4 divided by 2, that is 2. That is for a 4-sided polygon. And name of the 4-sided polygon is quadrilateral. For a quadrilateral, we can draw 2 diagonals. for a quadrilateral. Without drawing, we can find out using the equation n into n minus 3 divided by 2. Here for a quadrilateral, 2 diagonals we can draw. Now if it is 5, number of sides is 5. Then this have to change. Wherever n is coming, you have to write 5. So this becomes 5 into 5 minus 3 divided by 2. That is equal to 5 multiplied by 5 minus 3. 5 minus 3 is 2. That is 5 into 2 divided by 2. That is 10 divided by 2. That is equal to 5. That is a 5-sided polygon. Name of the 5-sided polygon is pentagon. Pentagon we can draw 5 diagonals because we got the answer here 5. So 5 diagonals we can draw in a pentagon. In this way, any figure is given. Any figure means any polygon is given related to number of sides. According to number of sides, we can find how many diagonals we can draw using this